Today we're going to talk about dividing polynomials using long division. Now, I'm guessing for some of you it's been a long time since you've done any kind of long division. So I'm going to very quickly do a review long division problem. You do not need to write this down or put this in your notes unless you find it helpful. So let's just quickly run through this long division problem. I would start by figuring out how many times does 7 go into 58? And the answer is 8. Then I have to find the remainder. 8 times 7 is 56, remainder of 2. We bring down the next number and repeat the process. 7 goes into 27 3 times. 3 times 7 is 21, so this time a remainder of 6. And finally, I bring down the last number. How many times does 7 go into 66? It goes in 9 times. 9 times 7 is 63, remainder of 3. And I can express my answer as 839 and 3/7, where 3 was that remainder, 3 left over out of 7, the divisor. So I'm doing this review problem because when we divide polynomials, we use the exact same process. We start by dividing, then to find the remainder we have to multiply and subtract. We bring down the next term and repeat the process. For my first example, let's divide 3x squared minus 5x plus 6 by x plus 2. I start by writing this as a long division problem. Then to do the division, I look at the first two terms only. 3x squared divided by x is 3x. So the first part of my quotient is 3x. I'll write that down. And then to find the remainder, I'm going to have to multiply 3x times x plus 2. That's 3x squared plus 6x. Finally, we subtract both terms to find the remainder. The 3x squareds go away as they should, and minus 5 minus 6 is minus 11, so minus 11x. Now I bring down the next term and repeat the process. Looking at the first terms only, I'm going to divide negative 11x by x. That gives me negative 11. I'm going to multiply negative 11 by x plus 2 to find that remainder. That would be negative 11x minus 22. To find the remainder, we subtract both terms. And notice here, I remembered that subtracting a negative turns into addition, and that's why I changed those to plus signs. In other words, 6 minus negative 22 is 6 plus 22, or 28. There's no more terms to bring down, and so I'm done. That's my remainder. To finish the problem, I write down the quotient, the 3x minus 11, and then I'm going to write that remainder as a fractional part, exactly like what I did with numbers. I write it as the remainder, which is 28, over the divisor, x plus 2. All right, let's do one more example. I'm going to start by writing this as a long division problem. Now when we do long division, it's really important that all of our like terms line up. And for that reason, if your problem has a missing term, an exponent of the variable that's not present, you have to put in a filler term so that everything lines up properly. In this case, we have an x to the third, but notice there's no x squared. That's why I put this 0x squared term into my problem. So I start with the division, first terms only. 6x to the third divided by x is 6x squared. So I divided, now I multiply. 6x squared times x minus 3 is 6x cubed minus 18x squared. And then I'm going to subtract to find the remainder. Once again, if you're subtracting a negative, it turns into a positive. So that's where the positive 18x squared came from. I bring down the next term and repeat the process. 18x squared divided by x is 18x. Multiply. 18x times x minus 3 is 18x squared minus 54x. I subtract. Once again, subtracting is the same thing as changing the signs and adding. So remainder of 58x, bring down the minus 2, and looks like we have just one more division problem left. 58x divided by x is 58. We multiply. 58x minus 174 and subtract to find the remainder. There's no more terms left, and so I have got my answer. I'll write the quotient followed by the remainder over the divisor. Hope this helps with this section. As always, let me know if you have any questions.